Hey there! Similar to the last video on the channel, this video will dive into another factor that affects rockets on their way to space: gravity. Well, let's get spacey. The gravitational force that exists on Earth makes life as we experience it, and has a range of implications on almost everything in this world, of course including rockets. The gravitational force an object experiences is what gives it its weight. For example, you may weigh 60 kilograms, a car 1500 kilograms, and so on. Technically, weight is expressed in newtons and can be derived using the formula W is equal to mg, where W stands for weight, m for mass, and g for the acceleration due to gravity, which on Earth is 9.8 meters per second squared. So we've established that gravity gives objects around us, including rockets, a particular weight. In a previous video on rocket propulsion, we had come to the conclusion that a greater exhaust velocity translates to a bigger change in velocity, or acceleration, with a given amount of propellant. However, that was true for free space, but the gravity on Earth introduces a new concept called thrust-to-weight ratio, or TWR. Every rocket produces a certain amount of thrust with its engines and preferred method of propulsion, but what matters is the ratio of the thrust to the weight of the rocket it's trying to move. This is the thrust-to-weight ratio of a rocket, and what this means is that the more thrust a rocket has compared to its weight, the greater its acceleration, and hence faster it moves. Let's start by taking a look at these two rockets, lifting off from Launch Pad 39A at Kennedy Space Center, Florida, at different points in time, of course. We can compare the speed at which they lift off by looking at its position relative to the launch tower at the same point in time after liftoff. Here, we can clearly see that the space shuttle accelerates faster than the Saturn V on the right. And this can of course be explained with some simple math involving thrust and weight. First, we start off with the gross weight of both rockets, which is about 4.5 million pounds and 6.4 million pounds each for the shuttle and Saturn V respectively. Then, the total thrust produced by all of its engines is 6.9 and 7.5 million pounds of thrust each. Now, what's important here is the excess thrust that is available to lift the weight of the rocket. By subtracting the two values here, we get an excess thrust at liftoff of 2.4 million pounds with the space shuttle and a comparatively lesser 1.1 million pounds with the Saturn V. Now, the actual change in speed that we saw earlier in this video is not only dependent on the excess thrust, but also the weight of the rocket that is being pushed up. Taking this into account, for the shuttle, this value is about half a g, or half the force of gravity on Earth, and slightly less than a fifth is the Saturn V. This explains the earlier observation of the space shuttle leaping off the launch pad considerably quicker than the Saturn V. Well, that's it for this video. If you enjoyed it, please consider liking and subscribing, and leave a comment down below for any questions or suggestions. I'll see you in a bit, and until then, stay spacey.